Okay, we got to do a bit of background chitter chat before we go too much further with this. What is the title of this page? Factoring polynomials. We have already dealt with factors in this year, yes? We were doing prime factors. You already know how to do those, yeah? But your past teachers did something else with you with factoring, and I'm going to remind you of that. But before we go any further, I need to ask and make sure everybody is on the same terminology wavelength. And what I mean by that is, can anybody tell me what a factor? Give me the definition of a factor. Do not give me an example. Can you give me a definition of it? Anyone? Okay, we'll cheat. How many of you can give me an example of a factor? I'm the worst math teacher ever, apparently, because all 30 of you can't tell me an example of a factor. Anusha.
2 is a factor of 4.
2 is a factor of 4. Why?
Because 2 times 2 equals 4.
Excellent. 2 is a factor of 4 because 2 times 2 equals 4. So now I'll ask again. Give me a definition of a factor. Karen. Any two numbers that multiply together are factors. Any two numbers. Marcos, say any number. Don't be a wise ass and say the words any number right now. Because that's what I would do if I were you. Marcos, say any number. Any number. Marcos, say 3. Excellent. Jacob, say 6. That means they are factors. What number are they factors of? 18. These are the factors. This is the product. Yes? All right. The next thing I need to remind you of is this. 1, 2, 3. 1, 2, 3, 4, 5, 6. 3 by 6, 18 in the middle. Yes? We know all this from long, long ago. Right? Okay. So what then is this right here? Are those factors or are they a product? Those are factors. Why? Because I'm going to multiply the two of them together, right? Factor 1 is 4. Factor 2 is x minus 5. Now, how can x minus 5 be a single thing when it's obviously two terms? The brackets. Well done. Everybody good? Great. Now, we already have talked about what is actually happening here, haven't we? Right? This is x minus 5, 2, 3, 4, 5. How many times? 4 times. So this must be my answer, correct? Which I can write right over here quite plainly. 4x's and minus 20. Yeah? And of course you have learned to do that algebraically as well, right? Okay, so if this is the product, where do the factors live? On the outside. So how do I find them? Well, it's pretty simple. There is one of the distances on that side, correct? What did I just draw? A single x. And then there's 5 of these little guys, because you are only looking at this edge. Just like up here, you're only looking at 6. So it is x minus 5. Minus 1, minus 1, minus 1, minus 1, minus 1. What is it down this side? You are only looking at this edge. 1, 1, 1, 1, 1, which is 4, just like you are only looking at the 3 there. Yeah? Excellent. Now, what would happen here in a picture? Where do the factors go? Because we can't really say like we did here, can we? This was x minus 5, which we could draw, and then we drew it 4 times. Can I do that here? No, because there's unknowns in both. So now I have to work the other way and only work with the factors. What is one of the two factors? X plus 4. Why is x plus 4 a single factor when it is two terms? Brackets. So I have x plus 4 as factor 1. So I would draw that here. X, 1, 2, 3, 4. What is the other factor? X plus 2. And then I would fill it in. Now this is where people were having trouble yesterday. I have that width and I have that length, making an x squared. Then I have that and that, making an x. Then again, then again, then again, then again, then again, and then that and that, making little guys. And what is the answer? X squared
plus
6x plus 8. Now, that's pictures. I gave you two other ways to do this. The first was the distributive property. You guys have been taught the little shortcut word FOIL. I don't like that word because it only works with binomials and binomials, so I don't like to use it. But what I will use is the distributive property. X goes through both, then 4 goes through both to get x squared plus 2x plus 4x plus 8, which gets me x squared plus 6x plus 8. Holy crap. And then, because I love you as much as I do, I even gave you one more shortcut that you could use whenever the first term was just a single letter. What was that shortcut? Does anyone remember? It was a long time ago. It is x squared, then plus a plus b x, and then plus a times b, which in this case is x squared plus a and b are 4 plus 2 x, plus a times b is 4 times 2, which is x squared plus 6x plus 8. And all of you have been shown all of these three things. All of you should be very comfortable with all three of them. And you are, yes? Wonderful. Now, let us move along then, cabbages, to this line right here. Earlier in this semester, when I said factor 12, what did we do? We broke it down. How? Prime factors in the tree, yeah? We went 12, 2, 6, 2, 3. Yeah, yeah? Yeah, yeah. Now, another kind of factoring that you have done in your past is when your past math teacher asked you for pairs of factors. And most likely you saw something that looked like this. 1 and 12. Because 1 times 12 is 12. Then you did 2 and 6. Because 2 times 6 is 12. And then you did 3 and 4. Because 3 times 4 is 12. And you got all of the factors of 12, not just the prime factors of 12. Does everybody remember seeing something like that in their past? And you wrote them out in pairs, 1 and 12, 2 and 6, 3 and 4. Yeah? You've all seen that at some point, correct? Good. They both have their uses. This is what we are going to use a lot of this unit right now. But when the numbers get bigger, you're going to need to do this in order to do this. Everybody cool? All right. Let's carry on with the theory behind it. We are not going to get out algebra tiles because I do not have enough for everyone anymore because they keep getting thrown away and stolen and lost. I don't know what you people have. You're like pack rats. Ooh, algebra tiles. And you put them in your pocket and leave with them. I do not know why. It would be one thing if I found them strewn around the school from you throwing them at each other like ninja stars. But I don't even find that. They just disappear. And I don't know why. So, we are going to do this with a picture. Yes? All right. So we all agree that if we are going to factor something, we break it down into smaller chunks. Yes? Everyone agrees? Okay. So if I want factor 12, we're going to do one of these two things. Yeah? So here I have two different things here to factor. What are the ways I can break down 6 x's if I was drawing it? First of all, I would need to draw 6 of these long bars, wouldn't I? How can I break that down? There's only 2 ways. What are the 2 ways I can break down 6? Well, I can do 1 and 6 or 2 and 3. So when I make my pairs, it's 1, 6 or 2, 3, correct? So I could either write 6 bars horizontally or 6 bars vertically, couldn't I? Or I could write 2 bars 3 times, or I could write 3 bars 2 times. Does everybody agree with one of these? There's technically 4, but I didn't want to draw 6 vertical. Is everybody okay with that? Okay. Now, if I only had 6 and I said factor it, is this factored? Can I put either of them in the rectangle? Could I do this? 1 by 6. Would that work? Okay. Could I do this? 1, 2, 3. 3 by 2. Would that work? Could I do this? 2 by 3. Would that work? So everyone's cool with the 6x, yeah? Okay. So now what are my options for 3? I'll change color because now we're going to deal with 3. What are my options for 3? I don't have as many options, do I? What do I have? I can only be 1 and 3, yes? So I could either have 1, 2, 3, or 1, 2, 3, or nothing, correct? Now, you can see that both of these have been put together into one term, correct? So if they have both been put together into one binomial, then I must need something that works with both of them. Agreed? Can I put 6 and 1 and 3 and 1 into a rectangle? Shouldn't have used blue. That son of a... Can I put those into a rectangle? If I move that there, have I made a rectangle? Okay, let's try. How wide is the left side, Nick? 1 wide. Everyone agree? It's 1 all the way across, yeah? Okay. Let's pretend my product here is working. Let's just close it off because it's not working at all. Close. Open. I got 1 here, yeah? And then I got 1, 2, 3, 4, 5, 6, 1, 2, 3. Have I changed it at all? No, I have 1 times 6x plus 3. So I can't use that one because that didn't change it either. Okay? What else could I do to make a rectangle? So I know this guy doesn't work. I'm going to get rid of it. What about one of these two? Can I make a rectangle with one of those two? Which one? I'll separate them so it's easier to work with for you guys. Because this is all visual, yeah? Which one of those works with the one I've got left over? The one on the left or the one on the right? The one on the left. Why? Because I can go 1, 2, and 1, and then 1, 1, 1. Correct? If I tried to move these three here, do I make a rectangle? No, I got this little tail down here. Okay, Mr. Myers, you're not fooling me. I missed a guy. How'd that happen? Crazy. So could I do that? Does that make a rectangle? Oh, we're back to this not working. Does it? Does it?
Yeah.
So some of you will say 3, 3, 3, right? Okay. Does that make a rectangle? How long am I down this side? X, X, X. How long am I across this side? 1, 1, 1. Doesn't work, does it? Because this should be stretched then, shouldn't it? Everybody with me? Now, what has actually happened here? Well, 6 x's, then 1, 2, 3, right? What has actually happened to my 6x plus 3? I have actually divided it by 3, haven't I? Everybody cool? Which must mean, if this factored, what is this factor worth? What's that? 3. And what's this factor? 2x, not x squared, 2 x's, because there's 2 there, plus 1. That must mean that these are factors of that. Is everybody with me? And we can check it. Is 3 times 2x 6x? Is 3 times 1 3? Everybody cool? So we drew it, we divided it by 3, because that's what ended up happening, right? Do I need this step? Or can I just do 6x plus 3 divided by 3? Isn't this the exact same as this? It is, isn't it? Keep that in your head. We're coming back to it. Turn the page over. What do I have here if I was going to draw it? How could I draw that? I could do 4 big X's, or 4 big boxes, right? And in what configurations, Marcos? I got to draw 4 of them, yeah? And it's got to fit in a rectangle, yeah? So can I draw this? No. What are my options? Give me one of them. Straight up and down. I could do that. Yes? What's the other option? Horizontally. And what's the third option? 2 by 2. Correct? Okay. That covers the first term. But I've got a second term, don't I? What are my options there? I can do 3 by 2, or I can do 6 by 1, correct? Which one of those works with one of my 4s? 3 by 2, doesn't it? Because I got 2 there and I got 2 there. 2 is common, yes? So I'm going to take this and I'm going to draw it. I know I need 4 big guys. And now I need 1, 2, 3, 4, 5, 6 of them, yeah? Where do the factors live? Because that's the total I can see, 4x squared and 6x. Got them right there. What are the factors? Factors live on the edges. I'll wait patiently for everybody to tell me what the factors are. 2x, because there's one x, then a second x, and 1, 2, 3. What's down here? 2x. So what would I write if I was writing it out in factored form? What's this factor? 2x. What's this factor? 2x plus 3. And I would be done. All right? Now, what did I actually do to 4x squared plus 6x? I divided it by 2. So 4x squared plus 6x divided by 2 must equal this. Is everybody good? Everybody could draw these? We're not going to do this one yet because this one comes in later, and I don't like the way I've taught this in the past, so I'm changing it up this year. Please turn your page over to 127. In this blank spot at the beginning, I need you to write something. Factoring is the reverse, not inverse, is the reverse of polynomial multiplication. We achieve reverse through inverse operations. What? That makes no sense, Myers. But it does. Trust me. Okay, is everybody good? We're going to talk about what I mean in a moment. But before we go on, there's another warning I want to give you. Everybody do something to highlight the title of the kind of factoring we are doing right now. And then, please notice what I am writing and the way I am writing it. Why did I change pens? What does that type of writing mean? Means it's damned important. Always. When? Always. When? You mean every time? When? Always. Do this factoring. When? Any time you can. All right? Always, 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 always. Okay, and I'm going to show you how to do this kind of factoring in a moment. All right? If I were to give you 2x plus 4, and I wanted you to factor it, that means you're able, possibly, to reverse getting to this spot. What would reverse getting there? Read the first thing I said. Factoring is reverse polynomial multiplication, and we achieve the reverse through inverse operations. What is the inverse operation that gets you to a product? What gets you to a product? Multiply. So what gets you away from a product? Division. So I must have to do some division. If there was no 4 there, I would divide that by 2, correct? If there was no 2 there, what are my options for 4? I can divide 4 by what? I can divide it by 2, or I can divide it by 4. Couldn't I also divide both of them by 1? But that wouldn't change it, would it? So we usually throw 1 out the window. There's a time and a place to divide by 1, and I'll get you 2 there. But right now, we only care here. Now, is this a monomial, a binomial, or a trinomial? It's a binomial, which means they are working together, yes? So I had better find something that works with both of them. What is it? 2. That is how I do this factoring. Everything else is a path from this. Everybody cool? So let's do this very first one, then the second one together. What are my options for dividing stuff out of 5? I can only take 1 or 5, and Myers just said we throw 1 out the window. So we're going to divide them both by 5, correct? What does that give me? What is 5x divided by 5? X, because 5's cancel. What is 5 divided by 5? 1. Now, you people are intelligent. I have made 1 binomial, yes? Which means I only have 1 factor. How many factors must I have? I need at least 2, don't I? Or I don't have factors, because you need 2 things to multiply together. So what do I need here? What have I done? I gotta multiply it by 5. Everybody with me? Great, do it for that one. Tell me what your answer is. What are my options for dividing 6 and 3? 6 is 2 or 3, and 3 is 1 or 3. But we always throw 1 out, so it's only 3. Which one do I have to use? 3. Now you should notice, whatever I divided by ended up out front, and whatever the answers were ended up in the middle. Is there a way to check to make sure you did it right? So you don't have to go, Mr. Myers, am I doing this right? Of course there is. If we reverse to get the factors, then if we go forward, will I get the answer? Sure. What's 5 times x? 5x. What's 5 times 1? 5. What's 3 times 2x? 6x. What's 3 times 1? 3. Can you always know if you did everything right in this unit? Yes, because you can all multiply. Everybody good? Now, you all know I hate shortcuts until you see why it works, yes? Has everyone seen why it works with both pictures and numbers? So now I will give you a shortcut. It's not a shortcut, it's a checklist. Okay? So if you do not actually understand what is happening here, at the very least you can do the math. All right? The checklist is as follows. To GCF any polynomial. 1. Decide on the GCF of all terms, which means you have to check numbers and variables. That is step 1. So we checked. 5 was 5 and 5. That's the greatest common factor to both of them, yes? In 6 and 3, I could be 2 or 3 or 3. 3 was the greatest common factor to both of them, yes? So everybody can do that one, right? What was step 2? Once I had that GCF, what did I do with it? I divided, right? I saw a bunch of people doing this. That's divide. Step 2, I divide all, and I should capitalize that, divide all terms by the GCF. And what was step 3? How did I write my answer? What went first? Right. I write the answer. Right. Answer, not nosser. Right. Answer in this form. GCF. And then, what do you call the answer when you do a division question? Does anybody know the proper word? Quotient. Quotient 1 plus or minus quotient 2. When do you stop writing quotients? When you run out of them. So you do that up to quotient n, your last quotient. Is everybody good? So now either you understand how to do it on the left, or you can follow a simple 3-step checklist. One of them is better than the other, but both will do the job for the 10th grade. Okay? Let's try it, shall we? This one right here. Uh-oh, it's a trinomial, so it looks different. It's wearing a top hat and a tuxedo. Do we treat it any differently? Of course not. What is step 1? Decide on the GCF. What is it? 3. Got it in my head. It's 3. Now, divide all the terms by 3. So step 1, GCF equals 3. What's step 2? Divide all the terms by 3. Divide by 3, divide by 3, divide by 3. What is step 3? Write the answer. What is my GCF? 3. What is the first quotient? X squared. What is the second quotient? 4x. What is the third quotient? -2. Do I keep going? Why not? Because I'm out of quotients. Easy peasy, yeah? Okay, what's different about the next one? It looks different, but do we treat it any differently? No, just like people. Or when the aliens come and they're purple with yellow polka dots. If they aren't killing us, we say, hey bro, let's party. Dude, they traveled from another galaxy. You don't think they figured out English? I know it's complicated, but come on. You all learned it.
But we're not learning alien language right now.
Exactly. And how far off our planet have we gotten?
The moon.
There you go.
What about Mars?
No person has been on Mars.
2020. Give it 2 years.
We can't even get a person to Mars safely. Why would we bother learning an alien language? However, when we are able to, if it happens and it won't, we could go to other stars. Well, of course, we're humans, so we won't bother. Unless, of course, we speak another language. For example, if a German astronaut goes to another star, he will probably try, or she will probably try to learn the alien's language, because Germans are aware that you can have more than one language in your head. Only English speakers and French speakers think you can only have one language in your head. Because it's only the English and the French that feel there's room for one language in your head.
Do you think there's aliens out there?
Of course there's aliens out there. The universe goes on forever.
Yeah.
It doesn't matter what your religion is. If you believe that God created, or whatever your God is, created the universe, and the universe goes on forever, then you should have no problem believing God might very well have created other aliens.
Yeah.
God created people in his image. Have you met God?
No.
I haven't. Maybe God is yellow with polka dots.
In our religion, it says God produced organs for his continuous.
What is the common factor? Remember, check numbers and variables. So, all of you have no problem spotting 2, but x squared and x. How many x's could this guy give to the party? How many can this guy give? So I only have one x, that's the GCF. So what do I do with that GCF? I'm on to step 2. What do I do? Divide all the terms by that. 2x, 2x. Then I write my answer in what form? What's the GCF? 2x. What's quotient 1? 2x. What's quotient 2? Positive 3. And I stop. Easy peasy lemon squeezy. Here is where you're going to make a mistake. Unlike elementary school, where you get taught one thing and then you do it a million times and never do anything more with it, that is not high school. This is but a first step. Here is what is going to happen to you when I give you your first test on this. You are going to be able to do this. But then, inside here, you're going to be able to do more factoring of a different type. There are 4. You will learn them all. What you will do is you will forget about that first one. Not so bad in math class. Kind of difficult if you forget a value out in the real world, yeah? So don't. Everybody cool? I am warning you now. This is but a first step, which means you must remember it even if there is 25 steps to do. Alright? You will not get a gold star if you master this. You will get 1 point of the gold star because there are many steps yet to come. Everybody understand? Derek, hit me. Okay, this is really 4 times x, correct? And this is really 6 times x, correct? Which means I'm dealing with 4 times 6 at some point, right? 4 and 6. And I'm dealing with xx plus x, yeah? Okay, if there were no x's there, this is pretty similar, yeah? 6 divided by 3, 3 divided by 3. Because there was not an x in both. But here, there's an x in both. So when I divide, I could also divide out an x from both of these because they both have one x to give me. So I have to include my variables. All right, now there are 4 questions on this page to do. The first one is very straightforward. It is exactly what we have just done. Everybody, please attempt the first one. Remember, you have a checklist right there. Follow it through. Go. Just the first one. That's all I want you to do. Because there's a little bit of a wrinkle all the way through here. But the first one is normal. What is my GCF? 5. And what else? X. Well, 5's not too hard for me to spot, but can somebody please explain why I am only using one x when I plainly have 2 x's there and 2 x's there? Because I only have 1 x to give there. Why am I not using any y's? I see I've got y's here. I'm asking you, can I use 1y? No, why not, Derek? Because 15x has no y's to give me. So I can only use what is common across all of my terms, which is a 5 and an x. So we have decided on our GCF. So our next step is to divide that GCF. Let us do so. What is 25 divided by 5? 5. What is xy divided by x? Y. Plus, what is 15 divided by 5? 3. What is x squared divided by x? X. What is negative 30 divided by 5? X squared divided by x is x. Y squared divided by 1 is y squared. And there's my quotients. Where do I write the GCF? Out front.
Can't you factor within the bracket?
Right now? How? Anusha has asked if I can factor inside the brackets right now. Can I? Is there a number that works with 5, 3, and 6? No. Is there a number that works with yx, and y squared? No. Now, here is a mistake a great many of you are going to make. Do not write down what I'm about to write down. Some of you will say, haha, got you, Myers. That's 3. It's 3x. You're not fooling me. And you'll divide them both by 3x. And you'll bring it out, 3x. And then you'll write 6x minus 8. And you'll stop. Of course it's 6. It's the greatest common factor. Now, if that happens, and you have done one factoring, what should you check for? What Anusha just asked about. Check if you can go further. Let's pretend you did this with 3 and you're like, damn, that doesn't look right. Oh, wait a minute, 6 and 8. It divides by 2. So this in the brackets is now 3x minus 4, correct? Where does that 2 need to go? Out here, just like when we were doing square roots. What was already out there? 3x, so what's out here now? 6x. Thanks, buddy. All right, what's different about B? It's a different letter. What do I want to do when somebody tells me they can't do math because the letters are different? I want to take my pen and stab it into my eye. None of you are going to do that, are you? Because even though it's an A, do the rules change? No. What else looks different? The 8's at the front instead of at the back. Does it matter? No. Why? Because it's all the same. Looks don't matter. So step 1 is decide on my GCF. What is it? Why is it only 2? I can quite plainly see there are A's all over the place. 8 doesn't have an A. They're all over the place, but they are not everywhere, are they? So I then divide by... Now, I've done this a little bit, yeah? I've practiced this a bit. Do you think I go divided by 2, divided by 2, divided by 2? No. I just write it once. Do I care if you like to write divided by 2, divided by 2, divided by 2? No. Would I ever take marks away from you for doing your work differently than me? No. So that is 2 first. Oh, wait, let me get hot pink going. 2. And what's the term? 4 plus 5a plus 3a squared. Done. Now, C is the first wrinkle. All right? What type of factoring are we doing? What's it called? It's written at the top of the page. Greatest common factor. Yes? On a number line, 0, 100, negative 1,000. What is the greatest number shown on this line? 100. Why? Pardon me? Because it's on the positive side and it is moved to the right. Yes? A lot of people have problems with this. For example, if I put negative 500 here, a lot of you guys forget that negative 500 is bigger than negative 1,000. Everybody cool with that? Okay. Now, that is going to change something in this type of question. So let's look at this question and let's decide on what we think the GCF is. Negative 5. But negatives are lower. Yes. That's the thing I want to talk about. Normally, we want the greatest common factor, yes? So, I agree that we would certainly use 5. And, of course, I would use CD because this guy's 1C and 1D to give, correct? But, when I actually do that, I end up with 5CD negative 4c cubed minus 6c squared d minus 5. Yes? We don't like this because there is a negative that is common to everything. We don't like that. Officially, what we don't like is we don't like this negative here. Almost every math teacher will say he or she wants this term to be positive. So if that is the case, they often like you to also remove a negative. Which means, because negative 1 divides into everything, we're always allowed to do this. 1 second, just let me finish drawing this. Keep it in your head. So I would divide this all by negative 1, which means this would be my answer. 4c cubed plus 6 squared d plus 5. Even though that is not the greatest number, because negative 5 is less than 5, we like the negatives to be as far to the front as possible. Is everybody cool? And again, that is a convention that math dudes have agreed upon. All right? You first, then you. Go. Okay. Your turn.
So if all the numbers are like negative, I can just put
A negative out front would change all the signs. Now, let me ask you this, because you have led to the very next thing that I'm going to say. Saying what I just said, what if I gave you this? 5CD negative 4c cubed minus 6c squared d plus 5. We still don't like this. We want that negative out at the front. So I would divide everything by negative 1, which would change that sign, and that sign. So what would I get? Negative 5cd plus 4c cubed plus 6c squared d, then a minus 5. Does everybody understand? If you've got negatives, we like them as far to the left as we can. Of course you can. It's about that time. You have to do this. But, again, this is a convention. This is something that we agree upon only for looks. Would you change, and don't write this down, would you change this if it looked like this? Would you change that purple one? Why? Because there's no negative at the front. And I remind you, this is a convention. We do this for looks, or if we need to change the looks of something. Everybody cool? That's going to come into play in a few minutes. Well, a few days. Marcos. I don't really care. Unless it's going to make a difference, and it hasn't made a difference yet. In a couple of days when we're doing some factoring, what I've just talked about is going to make a difference. and you're going to need to know when to use it. Okay? It's kind of like, oh, I got to put up a hook in my mom's house, and it's got a Robertson screw to hook it up, to hang it. You can't attack that with a flathead screwdriver. You got to go get the right tool for the job. Same thing here. All right? I'm going to show you when this trick is actually useful and when it is something we do just for looks. Everybody good? All right. Last question's right there. What's my GCF? There isn't one. Why would I put that question in the notes? It's not to trick you. It's to make you think. You are not learning something to do every time. You are learning something that you do when you need to. You can't do it here, so don't try to force the issue. Understand? There is no common factor, so it's already done. Everybody good? All right. Your job today, and you got 20 minutes to do it. It won't take you very long. All of page 128 and the first 4 questions on page 129. Stop when you get to number 2 kind of factoring that I haven't showed you how to do yet. Okay? Go. While you're working, I'm going to come around and I'm going to get your scores out of 8 on your homework. Okay?
This is also an assignment.
No. Oh, that's the other thing. No, it's not. You're going to get lots of practice on this stuff. Just do it.